Okay, so now we're going to go through PQ question 4. This is power series, PQ question 4. Okay, in part 1, we need to find the expansion of 8 minus x to the power 1/3 in ascending powers of x up to and including the term in x squared. Right, so what we're going to do now, okay, so we first write out the term. This is 8 minus x to the power of 1/3. Okay, and before we start, remember we want our constant to be 1, right? So observing that this is 8, what I'll do is I'm going to take out the 8. I have 1 minus x over 8 to the power of 1/3, right? Then from here, okay, 8/3, I mean I can just write it as 2, and then from in the internal portion I'm just going to write n times on my variable term 1/3 negative 2/3 and n minus 1 over 2 factorial negative x over 8 squared. Okay, and so we stop at x squared. Why? Because the question tells us so, including the term x squared, that's all. Okay, and so we stop here. Then just simplify the answer. You're going to get 2, this is 1 minus 3 times 8 x over 24, 3 times 3 is 9, negative 2 over 9, 2 over 9 becomes a negative 2 over 18, negative 2 over 18 becomes negative 1 over 9, this part is 64, 1 over 64, so we're just going to get negative 1 over 576 times x squared. I mean you can work it out this part, it's not so difficult, just take these and these, okay? Then eventually simplifying your coefficients, you have 2 minus 1 over 12x minus 1 over 288 x squared. Alright, what is it valid for? Okay, so again, to see a validity range, we just need to observe this, right? The variable term less than the constant term, so x over 8, we want it to be less than 1. Okay, or negative x, so it can be the same also. This is the same as x to be less than 8. We just multiply because the negative x and 8 can be the same. And this is the same. Negative x, modulus x is just the same as modulus x less than 8. And this means that you have x to be between 8 and negative 8. So this is the validity range. So it's always remember you must write the validity range. And next time we go to do part 2. We need to sub x equals to negative 1 and find an approximation for cube root of 3. Alright, so from here we sub x equals to x. So let's rewrite our answer. We know that 8 minus x to the power 1 over 3. Based on part 1, we have solved that this is approximately 2 minus 1 over 12x minus 1 over 288x squared. This is what we have. Alright, now we need to sub x equals to negative 1. So if they tell us to sub, we sub lor. Okay, we just follow. Yeah, x is negative 1, negative 1. Okay, this is approximately 2 minus 1 over 12, sub negative 1, minus 1 over 288, okay, and we sub negative 1 square. So we sub x as negative 1. And from here, you have on your left hand side approximately 9 to the power 1/3. On your right hand side, you have 559. 59, I mean you just calculate and add up everything together, this is about 28. Alright, is it what we want? So we need to approximate in our mind, we're thinking about cube root of 3. Where does cube root of 3 appear? How do you approximate cube root of 3? So I look at this, how am I going to get cube root of 3? Okay, so most people will do this. Most people will say, maybe what I can do is I just take 3 to the power of 2, 1/3, correct? And then they say, after that, they say the 3 to the power 1/3 square, right? So after that, what's 3 to the power 1/3? Need to be thinking, 3 to the power 1/3 is cube root of 3. Okay, it's just equals to the square root of. So if I square root both sides, 599 over 28, and this will be the answer. So a lot of people may do it this way. But then is it correct? Actually, the answer is not, because in this case, we want our answer to be in the form of m over n. It means we want the approximation to be a rational number. So is it a rational number? This is not a rational number. So we can't do that. Okay, so that's why you see I write it in red and I erase off. Okay, I erase off. And you have 9 to the 1/3. What can we do? What can we do? We think about 599 over 288. Okay, so what we can do is this. We can write this. Okay, so look carefully. you can write our 9 as 27 over 3. Okay, so it looks very challenging for the first time, but once you get the hang of it, you get better. So this 599 go to it. Let me just tidy up the 99 here. Right, then you can write 9 as 27 over 3. So 27 over 3, this is the same as 27 to the power 1/3 over 3 power 1/3. Okay, so can you see that the object of our desire is just at the bottom denominator here? So next, what do we do? So this is the same. The cube root of 27, this is just equals to 3, and this is the cube root of 3. So we're almost there. We just need to cross multiply, and 3 over cube root of 3 will be 599 over 288. Cube root of 3 will be approximately 864 over 599. Okay, this is for part 2. And how about for part 3? Okay, for part 3, x equals to 5 can also give an approximation for the cube root of 3. Now, would it be a better approximation than x equals to? So remember, will it be better? Because you think about it. Okay, so here we are using x equals to negative. So actually speaking, the value here is negative, modulus negative 1. The other value here is 5. Okay, so remember, we are looking at ascending powers, right? So we want x to be small or big, right? I'm sure you know we want x to be small. So which will be a better? Which will be a better? Which is closer? Small meaning close to 0. Okay, so we talk about being close to 0. Is negative 1 closer to 0, or is 5 closer to 0? Okay, so I'm sure you see that answer is negative 1, right? So since you say that so more negative 1 is less than 5, see, so of course x equals to negative 1 is a better approximation because it is closer to 0. And that's the end for PQ question 4.